Okay, so we're starting the recording. Welcome back from lunch.
Thank you.
We're in the same paste bin, and this time we're on line number 420. What we've done is we've now logged into our virtual machine. We actually did, a lot of the students did this in Windows for all the steps above here, but you want to log into your Ubuntu Linux machine for the next labs. And the only reason is because we're actually going to start driving around Metasploit. So we're going to be looking at the files that are inside these various folders in Metasploit. So our first line is line 420. We're going to cd change directory, and we're going to change directory into the tilde. And in Linux, tilde is your home directory. Excuse me. Home, tools, Metasploit, modules. Okay, now Metasploit in the modules folder, I showed you guys earlier, it had exploits, it had scanners, right? So we're going to go into the modules auxiliary. So auxiliary has a subfolder called scanner, which is all your different types of scanners. We're going to go into the port scan directory. So we're in the port scan directory, and we're going to do an ls. So if you see line 421, he's just telling you to do an ls, and you should see these files. Do you guys see those files in there?
Yes, sir. Correct.
Okay. Now, if you see a file and its extension is .rb, what language is that?
Ruby.
Ruby. What if it's .py?
Python.
Python. Good. What if it's .sh?
Shell script.
Shell script. What if it's .pl? Perl.
Perl.
Okay.
All right.
So what I want you to do is let's look at tcp.rb. So the way that we're going to look at tcp.rb is we're going to type cat space tc and hit your tab key. Okay, so I just do cat space tc, Tango Charlie, hit your tab key, it'll complete it for you, command line completion. Okay? When you hit enter, it's going to show the whole file. Now, how many of you guys are like, oh my god, like, that's a lot? Yeah?
Not anymore. Just kidding.
Now we can calm down because this isn't so bad, right? So I'm scrolling up with my scroll bar, right till we see the top of it, and the top of it, these pound signs. You guys see these pound signs? Can anyone tell me what these are?
Comments? Comment lines?
Yeah, so the comments. Okay, so he lets you know this module requires Metasploit. You're like, okay. And then he's going to require a module, right? And it's called MSF Core. So MSF Core is where all of these classes are loaded. And the method...
Sorry. I do have one question. I kind of got lost here. So we're currently working in Ubuntu console, is that correct?
Uh-huh. Were you able to log in?
Yeah, I was. I was just kind of, I'm not sure how to access this console here. Can you show me? It's not working anymore in Windows, I guess. So.
Okay. So
yep.
Let me log in just like you. It should look like this, right?
Yep.
Okay, so I'm logging in just like you. So as my machine is logging in, now what I need to do is I need to say, okay, I want to get to a command prompt. Do you have PuTTY?
Yep.
You have PuTTY on your desktop?
I don't. Do I need to download it?
Yeah, well, PuTTY is just a quick file, so...
Or you can use it from the Windows 7 machine.
Okay.
Yeah, so let's get you PuTTY.exe. It's going to be right here. So on your Windows machine, download this file and put it on your desktop.
On my Windows machine? Or
Yep.
inside of...
On your Windows machine.
No, I do have PuTTY installed on my Windows machine, actually.
Okay. So what we want to do is inside of the Linux machine,
Uh-huh.
we're going to go right to the top left corner.
Okay.
You want to click there. Okay? When you click on that top left corner, does it give you this dash home search box?
Yep. Terminal.
Okay. Now in there we want to type terminal.
All right.
Okay. So now we want to open up the command prompt, and the command that we want to use is ifconfig. ifconfig. ifconfig, like that.
Okay.
Okay? Now, it's going to give you an IP address right here. You see where it says inet adder?
Mm-hmm.
Okay? We want that IP address, because that is what we're going to put in PuTTY.
Okay.
So you take this IP address. I'm going to pop out of VMware. In PuTTY, I want to put that IP address right here.
Sure. Okay.
Now what I like to do is I like to give my machine a name, and then I save the name. Just makes logging into it a little easier.
All right.
Okay? Now when you log in, the username is going to be strategic sec, all lowercase. The password is going to be strategic sec, all lowercase. Okay? Now when you're doing this with PuTTY, you won't see the password as you type it.
Yeah, it's fine.
Okay? Alright, now we get to the reason why I love PuTTY so much, and that's because in PuTTY, let's say you copy this text right here on line 420. You highlight this and copy it. In PuTTY, all you have to do is right-click. So I'm going to highlight this and copy it. When I go to PuTTY, all I do is right-click, and it'll automatically paste.
All right.
Okay, does that work for you?
Yep, I'm in. All right.
That's awesome.
Alexander's back. Yeah.
Welcome back, buddy. Okay, so now I want you guys to cat that file. You remember what we talked about? Cat space TCP, and then hit your tab key. Now I'll give you guys a little Linux trick. When you cat a file, you can pipe. Okay, the pipe is directly above your enter key. So you can cat tcp.rb, pipe, space the word less. Okay, I want you guys to give that a try.
Uh-huh.
Okay, now what it's going to let you do is it's going to let you use your arrow keys so you can scroll up and scroll down through the text. Okay?
Yep.
So now we're going to scroll up and scroll down through it. Okay, so what I'm going to want you guys to do is, we already figured out these are comments. So this is comments. You're going to require a module, right? And I want you to think of buckets. So you got the bucket for modules. Modules are always going to start with require.
Mm-hmm.
Then inside of that bucket, you have classes, right? And we've already built classes earlier today. Inside of those classes, you have methods. Is starting to make sense, guys?
Yes.
They're just containers. That's all it is.
Mm-hmm.
They're just containers where stuff is. Okay? So for this class, it's going to be the Metasploit class, right? And he doesn't pull in all of Metasploit. What does he pull in?
Auxiliary.
Right. So he doesn't pull in encoders. He doesn't pull in payloads. He doesn't pull in, exploits. He's just pulling in the auxiliary stuff. Right? So, okay, what I want is I want the remote TCP stuff. I also want what?
The scanner.
And?
Report, huh?
Because I want to be able to, print stuff out to the screen. Okay? So he creates a method, he calls it initialize, and then this metadata, right, he calls it super, what's it going to have? The name of the module, you see?
Mm-hmm.
The description, oh, okay, well, this is what it does. Okay? Who wrote it? Have any of you guys ever heard of a guy, HDM?
HD Moore.
HD Moore, there you go, right? So HD Moore and Chris Catterjohn, they wrote this, and then it uses the MSF license, right? So that just tells you what type of open source product that it is. Now we've got some options. So our next thing, he says, okay, well, let's register options. He says, all right, well, what options do I have? Okay, so option string. We're going to have a new option, and it's going to be called what?
Ports.
There you go. So ports has to be a valid entity. So we say ports equals true, right? So that just means there's something in it, right? It's a valid entity. And then the ports to scan, right here, he's telling you how to write it. See that? So you can say ports space 22 to 25, comma 80, comma 110 to 900. Make sense?
Makes sense.
Okay. Then what's your next option, guys?
Timeout.
Okay. So now he says, okay, now this will time out in however many milliseconds that we set it to. Okay. If you have a network with a really high latency, you might set the timeout to be higher. Right? So like, if your network is really latent, really congested, really slow, you might say, you know what? Packets don't return as fast as they should, so let me give them a little bit more time. That's the timeout. You can say concurrency. Okay, well, if you check one port at a time, that's really slow. But if you check 10 ports at a time, that's really fast. Does that make sense, guys?
Right.
So on really high latent networks, you don't want to have a high concurrency number. You want a low concurrency number because you're not trying to beat up the network. Okay? And then He's got deregister for our ports. We'll get to that a little later. Okay. So now he has another method, and this one is called what?
Run host IP.
Okay. So run host, and you want run host to work on the IP address you give it. Does that make sense?
It makes sense.
So this will be called an argument. So you're going to say run host, the method run host takes the argument IP, right? So it's basically like you say, what do you want this to run on? What do you want this to work on? What do you want this to work with? Okay?
Mm-hmm.
So he's going to run host, and the parameter you give it, the argument you give it, is an IP address. And then he creates another variable called what?
Timeout.
Mm-hmm. And you can see that he pulled that from timeout from earlier, huh?
Mm.
Okay. Then he creates another variable called what?
Ports.
There you go. Okay. Now you have something called Ruby, right? Rex, right? Rex, socket, port spec, right? Port spec, crack, data store, ports. So what he's doing with this is he's just being lazy. He doesn't want to write all of this out. Would you want to write all this out?
No.
No. So you get really lazy and you make it equal what?
Ports. Mm.
Yeah. Now it's really easy for you to say if ports is what?
Empty.
Yeah. In other words, you can't port scan something without giving me a list of ports to scan, huh?
Mm.
Right? Hey man,
Right.
if ports is empty, raise an error, raise an exception, right? Raise option validator what?
Error.
Yeah, hey brother, you didn't give me a what?
Give me something.
Yeah, give me something to work with, and we always what?
The end. Don't forget that end.
Always end, right?
It will loop forever.
Loop forever, right? Okay, so now, while ports, the length of ports is greater than 0. So as long as you give me a valid port, do something. So he's going to create T, he's going to create R, and he's going to say begin 1 up to the number of currency, do ports.shift, break if not on this port, and then he starts filling in framework threads spawn, self. I'm not going to get into this today, so I know there's kind of some smoke and mirrors, but I'm not going to teach you this yet. And then IP is a placeholder, and then port, you provided it. You remember I taught you these hashes and squigglies, right?
Right. Yep.
Just placeholders. That's all they are. They're placeholders. This is information you gave it. You gave it the IP address. You gave it the port. Right? And then he's going to put all that stuff into what?
To that T.
Mm-hmm. So, okay. So if all that stuff is the case, do port begin, connect to it. Connect to that port on that, come on, work with me,
IP.
guys. On that IP, and use this timeout.
Right. 1000.
Uh-huh.
That's like the threshold, or that's something, or you can always change that too.
Yeah, that's how long we're going to wait.
I see.
Yeah, so you're going to wait that many milliseconds. Now, the reason he divides it by 1,000, milli is 1,000. So if you're going to wait 10,000 milliseconds, when it prints out, because he's dividing it by 1,000, it'll be wait 10 seconds.
Oh.
Okay? Okay, and then he's going to print status, and it'll say what?
IP.
This IP, and
The port.
is...
It's open.
Uh-huh, and for every one of those, you're going to stick that in...
To R.
Uh-huh. If it doesn't work, right, look, rescue, refuse, print status, what?
IP import.
That IP import is
Close.
That's it.
Just because the port's close, yeah.
Uh-huh. And then this is just error catching, right? Okay, if that breaks, raise an error. You see that?
Right.
Yeah? If that breaks, raise an error. If you hit Control-C, right? In other words, like you ever have a scan that's taking too long, so you're like, you hit Control-C, you want to move on? Right? That's what you're doing here. Okay, so if you Control-C, he's going to raise it. Okay, if there's anything else that blows up, we raise E, that just means the error. Right? So let's say for whatever reason, your network card goes dead. Right? In other words, you lose like your link connectivity. Right? So you can't connect to the IP import, but it's not because it's blocked by a firewall. You don't have network connectivity. That's probably going to cause an input-output error or some sort of error here. It's going to cause some sort of error. And then we're going to print that IP, that port, and then we got this exception, and then he's going to print the whole error. Then he's going to print the whole backtrace. The backtrace is all the error message on the screen. Okay? And then he disconnects, and then he does that for every single port. That's all he's doing. Okay? And then I'll loop through it, and if I have to kill anything else that's running, kill it all. Right? Like if it's a timeout, like you waited too long, I can't connect to it, so he just kills it. So for each one that it took more than our timeout time, kill it. Right? r.each do res, and then print it out. Report it. This host, right? This port is in this state, and that's how it prints it out to the screen. Okay? Now again, guys, I know it might be a little complicated. My goal right now isn't to teach you how to write these yet. I just want to get you to start being able to read them.
I see.
You know what I mean? Like, the biggest thing with learning Metasploit is to get comfortable driving around it. Now, guys, you can move your up and down arrow keys, right? If you press Q, what happens?
You exit?
Yeah, it pops you out, right? Okay. So now that it's popped us out, what I want to do is we want to jump into some Metasploit fundamentals. Metasploit works in a couple of major modules. Okay, so your first module is exploits. Right? That's kind of easy. Your next module is your auxiliaries. These are going to be like your scanners, your sniffers, your brute forcers, all kinds of other stuff. So basically anything that's not an exploit. Then you're going to have payloads. So a payload is what do you want the computer to do after you break into it. So like you launch the exploit. Once the exploit runs, what do you want it to do? Do you want it to open a command prompt? Do you want it to add a user account to the machine? Right? Open a command prompt, we call that a bind shell. Do you want it to make a command prompt that connects to you? We call that a reverse shell. Do you want it to add a user account? We call that a user add payload. Right? You might be dealing with an intrusion prevention system. And if the intrusion prevention system is out of band, in other words, it's not in line, then what happens is the intrusion prevention system, please forgive me, I'm going to try and draw this with my finger, but you can have an IPS that's dual homed, right? So it's got two NIC cards in it. Traffic goes this way through it, right? If the IPS triggers a rule, he drops the packet, right? That's an inline IPS. That's what that's called. So you've got an inline intrusion prevention system. Now what if what if hanging off your core switch, you want to put your IPS off a span port on the core switch? So this is the core switch for your company. The core switch usually breaks down into subsidiary switches. Please forgive me, I'm drawing this with my finger. This is so much easier on a whiteboard. Okay, so it comes in from the internet, usually hits your firewall. Okay, traffic comes in and does this, right? Now, you've got users down here. So, traffic needs to be able to go all the way to the users, but it's what's called out of band. Okay, this is called out of band. So what happens is you plug the IPS on the switch into what we call a span port. Can anyone tell me why you use a span port?
Capture all the traffic on the network.
Right, you capture all the traffic on the network. See, with a switch, traffic only goes to the port that it's destined on. So if the guy's over here on port 5, traffic only goes to port 5 on the switch. Traffic's over here on port 20, it only goes to port 20 on the switch. So if you plug in your IPS on port 24 on the switch up here, there's no traffic destined for port 24. So what you do is you span ports 1 to 23 so that they all show up on port what?
24.
That's why we call it a span port. So because the traffic is mirrored, some people call it a mirror port. Because the traffic is mirrored, it's not in line. It can't actively block. So what will happen is your IPS, if it's an out-of-band IPS, not an inline IPS, when he gets the alert, the attack actually made it down here to the victim. It showed up over here on the IPS, but it still made it to the victim. So now what it does is the IPS talks to the firewall and tells the firewall to create a rule blocking the attacker's IP. Because you know the attacker's out here somewhere, right? Well, you know your traffic is still going to get there. But what you don't know, well, you know that there's an inline, there's an out-of-band IPS. If you do the attack is going to get there. The attack will still be successful, but the defensive product is going to block your IP address. So you might use a user add payload. Don't create a command prompt. Don't connect to me. Create a user account. That way, when the IPS blocks my IP address, I will log into the victim from a different IP address. Does that make sense, guys?
Makes sense.
Okay. So we call that a user add payload. Right? So that's an example of a different kind of payload. You might have a payload that does VNC. Right? Your VNC payload will give you a GUI, right? So you're not driving a command prompt. So after the exploit, what do you want to happen? That's the payload. The next thing is you have in Metasploit what are called encoders. Your encoders, the whole idea behind the encoder is not to be caught by defensive mechanisms like antivirus and intrusion detection systems. So, let's say you're in IDS, and you go, okay, I see an attack, and the attack is 5 plus 5. It's a real hardcore, complicated attack, right? All right, so what you do is you write a rule for that, right? So now the attacker does what? What does the attacker do?
Change the payload.
Yeah, so he changes it, right? So now you write a rule for that. Now what does the attacker do?
Eddie, is there any blue ones? No. No.
How long can this go on?
Pretty much in perpetuity.
Yeah, this can be bad, huh? Can we do all kinds of payloads? All kinds of, not payloads, I'm sorry, encoders. This is kind of what an encoder is doing. The attack is basically the same, but you're making some sort of change to it. So although it doesn't look the same, it still does the same thing. So you may have an exploit that you send that's like an exploit for remote desktop. Well, they write an IDS signature for remote desktop. So in other words, they wrote a signature for 5+5. So you want to make your attack for remote desktop look like 6+4. Well, then they're eventually going to write a rule for that. So you want to make it look like what?
Same plus 3.
Does this make sense?
Yeah.
So that's what an encoder is doing. Changes the look, but it kind of keeps the same meaning.
Mm-hmm.
Does that make sense, guys?
Makes sense.
So you might do a specific type of attack and run it through a different encoder because you realize you're getting caught by antivirus. So you're like, let me try a different encoder. That doesn't work. You're like, let me try a different encoder. Or you might be getting caught by an intrusion detection system. So you might try several different encoders for the same attack. Right? That's the key point of why we have encoders. Okay, now our next thing that we're going to have are called NOPs. NOPs are a no operation. So your computer will often do stuff, and it may have to wait to do something. Like it may have to wait until something else finishes. So you might have a no operation instruction, NOP, no operation, short for no operate. So it just kind of tells the computer, hey man, don't do anything. Well, when you build exploits, you usually have to use NOPs. Like if we go look at an exploit, I can almost guarantee you that somewhere in there will be some NOPs. Here's some NOPs. NOPs are 90s in hexadecimal. See that?
Mm-hmm.
See he's got his NOPs? Okay. Then he puts 30 more of them. Right? So he said 0x90 times what? 30. If you're at your command prompt, right, your IRB, right, and you quote slash if you do that, what does it do?
Video.
Yeah, so it's like, just like if you do A, right, times 30, it's going to give you what?
30 letters.
30 A's, right? If you go, hey, give me 30 NOPs, he's going to be like, okay, here's 30 NOPs. Now, most exploits are always going to have NOPs in them. It's just one of these ways that you kind of set up memory so that when the buffer overflow happens, it happens properly. So you're almost always going to have NOPs. So what do people do? They write IDS signatures for NOPs. I'm trying to get a picture of it. So there's an exploit. And inside of the payload, what do you guys see? Yeah, big blob of knobs, huh? So what you'll see in a lot of these buffer overflow snort signatures, I'm trying to find the signature so you guys can see it, and it's so not working. Okay, give me 30 more seconds. Okay, this page takes a while to load. That's the reason why I said give me 30 more seconds. Okay, so what I want to show you is I want to show you a snort IDS signature so you can see what an IDS signature looks like, and then you'll realize, like, oh, you know, if they make an IDS rule, I have to wait for this thing to load. If they make an IDS rule, this is what they're expecting to see. Let me just move on while this is happening. Okay, in Metasploit, the important directories to keep in mind are modules, scripts, plugins, external, data, and tools. So we're going to go look at some of those. Hopefully my machine doesn't stay locked up. So let's go to 494 and 495. So you do your CD into Metasploit and do an LS in there, guys. So you CD to Metasploit, you do an LS, you see everything, right? Okay, do you guys see the modules directory?
Yes.
Okay. Do you see your external directory?
Mm-hmm.
Yes.
Okay, plugins,
Yeah.
data,
Mm-hmm.
okay. Right, so these are going to be like your major directories, right? So let's go ahead, CD tools, Metasploit modules. Let's do an LS in there. Okay, and you see that you have auxiliary modules, encoders, exploits, NOPs, payloads, right? Okay, let's go to 515, and let's CD to the external directory. Let's do an LS in there. Okay, the external directory is when you want to hook up external tools or external resources to Metasploit. So, how many of you guys knew that you could make Burp Suite, the web hacking tool, integrate with Metasploit? Right? You can make SQL Map, the SQL injection tool, integrate with Metasploit. Right? You can make Fast Track, the Pentest tool, integrate with Metasploit. Social Engineering Toolkit integrates with Metasploit. So you can make your external hacking tool talk to Metasploit. Okay, I'm trying to find these knobs for you guys. Okay, so you can make your external tool interact with Metasploit. I want you guys to do line 521, cd to the data directory, and do an ls in there. So we'll do 521, 522. Okay, the data directory is like all the helper tools. So like, for a lot of Metasploit stuff to work, it ends up needing like DLL files and resources and libraries and all kinds of other stuff. That stuff usually comes from the data directory. Okay? Why don't you guys try line 528 and 529? Let's go into the Wordless Directory. And when you do an ls in there, how many of you guys didn't realize that there was this many different word lists inside of Metasploit?
Right.
So, can you pen test Outlook Web Access? You see OWA?
Mm-hmm.
You see?
Yep.
Right? TFTP servers, Apache Tomcat, right? Joomla. Does this make sense, guys?
Makes sense.
Yep.
So, a lot of my experience with it is people have just seen so little of what Metasploit can do. Come on, get my computer. Come back, please. Hey, here's what I was looking for. Those are snort signatures. So snort can alert, log, or drop. So he'll alert, right, on any IP, right, on any ports, and the content that he's looking for is 90s. So what you want to use in Metasploit is a NOP generator. So in Metasploit, what you can do is you can say, don't use NOPs, use something kind of like a NOP. So what a NOP does, now the encoder is another way to say the same thing, right? But that's for attacks. NOPs are just for spaces that you need, like you need to set up padding. It's like filler. It's like, you guys ever go to the FedEx or UPS store and they put peanuts in the box that you're shipping? Right, to just fill the box, right? That's what NOPs are. Like, it's just padding that you put in the exploit so it all lines up properly, right? Okay, well, if you do 2 steps forward plus 3 steps backwards plus 5 steps forward plus 2 steps backwards, plus 1 step forward. Oops. Where the heck are you? How far forward did you go, or how far backward did you go?
3 steps forward.
So what's happening with your NOP generator is, rather than writing out a bunch of instructions that say, don't do anything but move forward 1 step, because that's what a NOP does. He says, wait 1 CPU cycle. Don't execute anything, but go forward 1 step. One second. Hola. ¿Me da 30 minutos, por favor? Gracias. Sorry about that, guys. Okay. Okay, so now let's go to line 535, and let's do 535 and 536. That's an interpreter. Okay, let's take an LS in there, and let's see what you got. So these are helper files that an interpreter is going to need. So can you guys see how there's metserve.exe, metserver server, right? So what that is when you break into a machine, you might want to turn Metasploit into a service so that it can keep running if the machine reboots. So in order to do that, you have to have both the client and the server that the client's going to connect to. So you see how these files are right there so that an interpreter can use them? Okay, time to get hardcore. Let's go to 560 and 561. What's in there, guys?
Exploits.
Yeah, what's in your wallet? Okay, so you can see that the exploits are broken up by what you're exploiting, right? AIX, Apple, Dial-Up, Firefox, FreeBSD, Linux, right? Whatever it is you're breaking into, right? You jump in there and you say, okay, well, this is what I want to break into. Okay, let's go 600 and 601. What do we got, guys?
There we go.
Okay.
Singles.
Payloads. Okay. Payloads, you're going to see that you're going to have singles where it's just a payload that just runs. You're going to have stagers. So the whole point behind these is, remember how I said you have like NOP slabs where you like pad everything? Well, what ends up happening with exploits sometimes is, sometimes you don't have enough space. Like sometimes you can't fit everything in the box. So the reason that you might use a stager, is because I can't fit the whole payload in the exploit. So I'm going to fit a stager, which may only be 30 bytes, 60 bytes. It fits in the exploit, but what it does, it's the first stage of the payload. And then it calls back home to pull down the rest of the payload. Does that make sense, guys?
Yep.
Okay. Okay. All right, the next couple things is just CDing around into the different folders, stages, and different things like that, cruising around into post modules and stuff like that. So why don't we take a break? I think we've been pushing pretty good. Let's take a break, then we'll come back, and then let's actually run a little lab where we use Metasploit against some stuff. Okay, guys?
Excellent.
All right, let's take a break and let's come back and attack some stuff.